Today I will introduce the paper Heuristic Network Security Risk Assessment based on attack graph. I divided the contents into 5 parts. Attack graph, heuristic algorithm used, risk assessment based on attack graph, simulations, and conclusions. First study, I will introduce something about attack graph. The rapid development of the internet has brought a lot of convenience and benefits as well as a lot of risks. Attackers prefer to exploit multi-vulnerabilities with a combination of several attacks instead of simply using violent cracking and botnets. Threat models and attack graphs have been used more than 20 years by enterprises and organizations for mapping the actions of potential adversaries, analyzing the effects of vulnerabilities, and visualizing attack scenarios. Attack graph technology displays possible attack paths in the network in a graphical form, helping defenders to understand the relationship between vulnerabilities in the target network intuitively so that the defenders can take corresponding defensive measures. We used two heuristic algorithms in this paper. Traditional algorithms can't always accomplish the task of extracting enough effective information because of variable and complex attack graph inputs. Especially enterprises and organizations tend to use microservice architecture and multi-cloud environments nowadays. In contrast, heuristic algorithms have the advantages of adaptability, self-learning ability, robustness, and high efficiency. In this paper, we present heuristic algorithms to complete the analysis of attack graphs to finish the security risk assessment, including fusion algorithm of particle swarm optimization algorithm and green wolf optimization algorithm for finding the spanning aberrations of maximum weight and improved genetic simulated annealing algorithm for finding attack paths with the biggest risk. The original GWO algorithm divide the wolves into 4 categories: alpha, beta, delta, and omega wolves. The leadership levels is shown in the figure 1. And alpha, beta, delta wolves has the first, second, and third best fitness. In the in the in the green wolf pack, these three wolves are responsible for leading the entire wolf pack. We can see the process in the figure 2. The new position of green wolf is determined by alpha, beta, and delta wolves. In each iteration, keep the positions of alpha, beta, and delta, and then update the positions of other search agent wolves based on their position information. The mathematic model of the process is as follows. Direction alpha is generated by the position of alpha wolf, and then according to the direction, we get the new position x1. Just the same, we got x2 and x3. The new position is determined by the average of x1, x2, and x3. The parameters c and A is determined by the number of the current iteration and two random number between 0 and 1. Our improved GW algorithms uh, is uh, is shown as the follow formula. GW algorithm only considers the position information of alpha, beta, and delta, and ignores the information exchange between brain wolf individuals and their own experience. So the idea of PSO algorithm is introduced to improve the position update process. We can see we can see the based position of wolf individuals is taken into consideration in the formula. The next, I will introduce the improved genetic simulated annealing algorithm. Genetic algorithm is an iterative process. Its global search capability is better than the local search capability, while simulated annealing algorithm local search capability is better than global search capability. Genetic simulated annealing algorithm gets the advantage of both GA and SA and becomes a comprehensive algorithm to ensure the diversity of the population. The crossover probability PC is set to a relatively large value in the early evolution, and PC is set to a relatively small value in the later evolution to ensure that it converges to the optimal result faster. Uh, uh, the mathematic model is shown as follow. We can see that the crossover probability PC is determined by the current iteration T. And the parameter PC1 and PC2 are two random number between 0 and 1. In the mutation operation, robust individuals try to reduce the mutation rate, and inferior individuals increase the mutation rate. The probability of child generation varies according to the temperature Tr. This process is shown as next formula. Risk assessment based on attack graph has three steps. Firstly, we found the aberrations with we found the aberrations of maximum weight in the entire attack graph. Secondly, we found a single attack path with the biggest risk in the graph. Finally, we got the importance of every state nodes in the graph. For entire attack graph, the problem of finding minimum weight aberrations is similar to the degree constrained minimum spanning tree problem for undirected graphs. Just the same as finding maximum weight aberrations. Heuristic algorithms have an excellent performance in solving such issues. We designed a coding method for directed graph spanning tree, which can be used in our heuristic algorithm, and the fitness function is as follows. We want to find the directed graph spanning tree with uh, with maximum weight. So we add the age chosen and got the sum. The process of coding the directed graph spanning tree is shown as the next figure. For example, in the first directed graph spanning tree, we choose the leaf J, which has the biggest neighbor in leaves. So we choose node 6. Then we add the start node to leaf 6 into the chord string P. So the first number in the chord string is 5. And then we delete the H from 5 to 6 and delete the node 6. We do the same thing. Until there is only one node left in the tree T. So the chord string P finally become 5, 5, 2, 2, and 4. How to decoding chord string P? We need to find nodes do not appear in P and arrange the labels in descending order from left to right. So we get 6, 3, 1, and then we suppose that I is the leftmost neighbor in P and J is the leftmost neighbor in the other string. In this graph, we got node 5 and node 6. Then we add H from 5 to 6 and then delete 5 and 6 in the two string. Just the same, we got the directed graph spanning tree. For single attack graph, we designed a new coding method that calls nodes with priority to obtain a flexible path. The adjacent nodes connected by directed edges need to be put into the alternative list L from the start node to the end node. Each time along the path, there may be multi-nodes as the next choice. The priority of nodes determines which next node to choose to put into the alternative list L. The fitness function is as follows. For this directed spanning tree, if we want to find a path from node 4 to node 6, node 4 has one choice, node 2, and the other choice is impossible. Then node 5 has two choices, 6 and 3. For single state, we want to get the importance of every state nodes. The importance of state nodes is one of the core indicators we can extract from attack graphs. The interpretive structure model. is widely used in various fields. It is used for attribute recognition, analysis, and investigation in the software development process. We can use ISM methods to identify the superior subordinate relationship between attributes and establish a structural hierarchy model. Using ISM can divide the attack graph into layers. Nodes and a higher layer are more important in the attack graph. We determine the importance of each layer according to the formula. In the process of analyzing the importance attack graph nodes, it is necessary to consider not only the neighbor of the node to be evaluated, but also the level of other nodes connected to the node. Simulations. To verify our model, we built a client-server web application that contains two cloud infrastructures connected to the internet through an external firewall. The structure is shown as a picture. And the attack graph of this structure is shown as the figure A. Every nodes and every edge is shown in the two tables. For example, state node 2 indicates admin or root access privilege. H3 indicates CVE 2010 30 egg 47, and the risk of H3 is 7. We analyzed the attack graph from 3 steps. First step, we find the aberrations of maximum weight, which is shown in the figure B, and then we find the path with the biggest risk, which is marked red in figure A. The heuristic algorithms fitness changed like the figure above, and the importance got from the attack graphs is shown in the table. We can see that state node 1 has the biggest importance, and state node 18 has the smallest importance. In this paper, heuristic algorithms are introduced to make risk assessments based on attack graph. No matter what the input attack graph looks like, heuristic algorithms can always complete the iteration and find the optimal result within a fixed time. The results generated by algorithms are related to each other, and they can be used to complete a comprehensive network risk assessment. Thank you for your listening.